How can we build trustworthy AI applications while leveraging the advancements and data processing capabilities of AI in our systems? This is a question that we want to explore together, also with the question on how you can employ a certain degree of governance for these kind of systems within your company. My name is Heiko Pfeffer-Ott. I'm the CEO of Westernacher Solutions. So let's get started. AI promises to change the world, and companies are betting on it in a big way. More than $50 billion have been invested over the span of the last 2 years into AI-based solutions. Perceived key advancements in AI come from the field of vision and language. Vision meaning vision transformers and vision action transformers. And in the field of language, we are talking mainly about large language models and respective transformer architectures. So use cases range from automated chat support to real-time translation of languages in the field of language processing, or from automatic detection of diseases in images through image processing, AI enhanced, to automated processes and robotics in warehouse management. And for sure, you already made your first experience or extended experience when employing and using AI for your systems in your company. If you're just getting started, it makes sense to start with one of these 3 categories you can see here: assist, automate, and accelerate. Meaning, assist systems often are co-pilots that are drafting documents, translating things, putting things together, both on a language level, but also can extract data and information from images. Automate processes are filling the gap in your system. They are taking an output from your workflow, from a single step of your process, and making it reusable in the next workflow process. The accelerate scenarios focus on making unstructured data structured, thinking PDFs that are really hard to process, and you can, through, for instance, processes like entity recognition, extract text, transform it in a way that it becomes machine readable. But there's one real challenge here, and this is that not even half of all people are willing to trust AI-based systems. And this is really a problem for companies, because this means that their employees are not really trusting the responses and results they got from AI-based systems. And it's also a challenge in terms of using or employing AI-based systems and partial solutions at the customer side, or perhaps even the company is not willing to let their vendors use AI-based technologies to create the solution itself. So where does this mistrust come from? And there are 2 key reasons for this mistrust. The first is stemming from a kind of uncertainty that we can observe. And it's coming from 3 main areas. The first is data protection, second, AI regulation, and third, business secrets. So there are a lot of laws and regulations that have either been introduced or updated in recent time, and they function a bit differently in different countries, and for sure on different continents. So for instance, data protection, like in the European Union, GDPR and the Data Act, they focus on protecting privacy, mainly personal privacy. AI regulation, like the European AI Act, enforce people to use AI in a compliant way and in a way where risks have been thoroughly analyzed. So they focus a lot on risk identification, transparency, and risk mitigation. Aside from the AI Act itself, there are other rules, regulations like NIS2, C5, which are not really tied to AI, but rather to cloud environments. But since these systems are becoming so big, we are often talking about more complex cloud infrastructures, so they, in some way, also become relevant here. And the third big step, and part of this, are your business secrets. So it should be of your own interest to protect the data, which might be your company assets or also your customer data. And it's worth protecting like personal data is anyway. You can address these challenges in terms of mistrust through a management system. And for quite some time, there's been a system around from ISO. It's ISO 42001 for artificial management systems. It focuses on risk mitigation, ethics, transparency, and it helps a lot in analyzing your system and build up trust with your customer. Of course, like always, you do not have to follow and employ the whole management system. It might be reasonable to focus on the aspects that help you in developing your solution in a significant way. The good news is if you are already working with the management system for quality management, for instance, also for information security management, these ISO certifications work together pretty well. The second reason for mistrust is a bit more complex, and it's stemming from our desire for determinism. When you are working with Excel, for instance, and you're looking at your screen and it doesn't make sense, normally what you don't do is you do not think there must be a glitch in Excel or a bug, but you think, okay, I must have made a typo, or there's something wrong with my data. But our trust in the system, in the application nowadays is pretty high. And there's a lot of research that tells why this is the fact. And it also tells us that it's not only the application we trust, but the provider. But the trust in the system is quite high. And we grew up with systems that work in this deterministic way. And this really changed with AI-based systems. Because now we have a system that for the same answer probably generates 100 different answers, and they might all be right or wrong. And the reason for that is that everything we do not tell the system leaves room for interpretation. And therefore, a lot of things might be a right answer to our request, knowing that a lot of things are free to be filled in by the system itself. So what should we do now that we know that this works in a different way? Trust no longer works in a sense that we are trusting a system. It works more like in human psychology, where trust has to be earned. It's a learning process, and it depends on a lot of things like references, assumed competencies, and observed behavior. A learning process that depends on seeing that the system is doing the right thing over and over again. And this is how you trust the person. And this is how we will in the future trust the system. So we really see a shift in paradigm here from a world where we were trusting just a system or an application or an answer that we get back, to a world where we are trusting a system around a model. So this is really the shift here. I will show you how you can, on the one hand, improve your system so that it becomes more trustworthy and provides the right answers over and over again as expected by users. And on the other hand, is trustworthy when it comes to regulation, laws, and data processing. And to understand this concept, we first have to take a step back and have to understand a bit how these systems work at all. So let's start with that. When you look at an AI-based system based on a large language model, but it works in the same way if it is a visual model, there are three core steps that are happening. In the first step, you take some data and there is a training process. And what you derive from the training is a model. A model is basically a neural network, so a network like a graph. And within each node, you have so-called weights. You can think of it like parameters. And they are configured in different ways. And depending on the configuration of these weights, a model processes later data in a different way. In a second step, you are deploying this model on some kind of infrastructure. And in a third step, we are talking about inference. So somebody asking a system a question, it's processed by the model, and what you get back is an answer. So these are the three most basic steps how these systems work. So you can take just any large language model and use it out of the box, but in most cases you won't get the results that you expect, because these models that have been pre-trained, so developed by a company, are rather general in terms of knowledge. So they have been trained on general knowledge like everything you can find in the web, and therefore do not have specific knowledge on things that are relevant in your domain or to your application scenario. So normally you have to improve the system to make it usable in your environment. And there are three things you normally can do to improve your solution for your domain. And you really have to understand how these three concepts work in general and where your data goes when you are doing that, because this is the basis for understanding how you can protect your data later on. And these three techniques are fine-tuning, RAG, and prompt engineering. Fine-tuning means that you are adding knowledge to the model through training. We have seen before, you derive a model by training it on data. And what you can do is you can take additional data that is very specific to your use case. And for instance, depending on processes that you employ in your company or working with data that you are using all the time. And you take the pre-trained model and add a second training phase where you adapt the weights of the model. So this training data is prepared in a way that they are input-output pairs. So you show the system, the model, the input, it generates an output, and you show the system the desired or wanted output, and through backpropagation, the weights, the parameters are adapted based on what is shown in this type of supervised learning. So what we are doing is we are actually changing the model, the parameters of the model. Second is RAG, which stands for Retrieval Augmented Generation. And it provides means to add information through additional sources. So what you can do is you can put all the documents and files and wiki pages and whatever that you deem relevant for an application scenario on your infrastructure. You simply link it. And what then happens if somebody makes a query? This query is first sent to this additional data source. So when we are doing normally a search, it means that we are pretty much matching words on a syntax level. So we are looking for documents that contain a certain word. RAG works in a different way. What it does is it takes your query and it transforms your query, which is pretty much a string, into a vector of numbers. It's called a vector embedding. And it does the same with all the documents in your additional data set. And what you then can do is you can make a comparison between the one very large vector you get from your query and the vector you have in your additional data. And thereby you can look for semantically similar information. So vectors that are close in space are assumed to have also a semantic relationship and closeness. And This means, for instance, when you normally look for headcount in your company, a normal search would look up the word headcount. What now happens is that documents are identified and returned that are somehow relevant for your headcount request. This might be a report of monthly joiners and leavers, or quarterly numbers from a specific unit that also contains information about employees. They are semantically similar and are identified as relevant. And they are passed back to the user. And now you take both your request and the identified documents and put it through the model. So now you can see where this name comes from. Retrieval augmented generation. You retrieve some data, you augment your query, and you generate text through inference. Third step or option is quite simple. It's called prompt engineering, which means you're optimizing your results through interaction. So you're simply more specific in the way you are interacting with the system. So instead of asking, what did Westernacher do? You are asking, what kind of projects or key projects did Westernacher Consulting execute in the field of warehouse management between 2024 and today? And it's more specific, gives more context, and ensures that you're getting better results. So these are the three key measures you can employ to improve the quality of results in your system. All these systems or all these measures have very different advantages and disadvantages, are often combined to find a good solution and have to be addressed in a different way. So fine-tuning, for instance, has a real advantage that it provides good opportunities to specialize your system, to include additional information that is relevant for your use case. For instance, we did have really great success by training the system with support tickets, for instance, where questions occur over and over again, which are quite similar, and this is a very good training set. The other advantage is that these modifications lead to quite fast inference, because you are taking the model and you are simply adapting the parameters. So later, through inference, the system works as fast as before. The disadvantage is that you need training data, and you do not only contain a few samples, you need a lot of training data, and sometimes it's quite an effort to obtain this training data and to put it in the right format to be used for training. Also, training is quite cost extensive, so you have to put in a lot of resources to retrain the model. Also, it means every time you want to add new information, you have to retrain. You have to take your model offline, retrain it, and put it back online with the new information to get an update. This is where RAG is really good. It's easy to keep up to date, because if you have some new information, you just add it to your space with your files and your data, and the information is there to be queried. It's also very good to provide a certain context for domain knowledge. The key disadvantages, and this is an area where we often in reality have to do a lot of working, is the latency. Because as you've seen before, the query doesn't really go to the model in an inference step, but first you have to create an embedding. You have to identify files that are similar, then everything goes back to the user, and then the inference starts. So this adds latency, and the system simply get slower. Also, you consume quite an amount of resources, because you have to store and create these vector embeddings to represent your request, but most of all, your data and files that you stored. Prompt engineering has the huge advantage that you do not need any new additional resources, and you directly see whether this worked out or not. Disadvantage, obviously, you're not really adding new knowledge The model cannot create something that it doesn't know. You can just be a bit more clever in getting it out of the system. And sometimes, and I guess you experience that already, it's quite different to create really good prompts that lead to the results that you desire. So now we have seen these 3 ways to optimize your system. We can fine-tune the model, which means our data is going into the model. Second option would be a RAG, which means our data goes in the form of files and documents as an additional source to the infrastructure. And the third step is giving better input when working with the system, which means our data goes into the model through the inference step. So although we are optimizing the system, our data goes different ways and is processed in a very different way. And this we have to keep in mind when we look at the overall process. And the good thing is now we know enough to look at a process that enables us to build more trustworthy AI systems. The process consists of 5 key steps: ingress, sanitization, retrieval, reasoning, and egress. Starting with the first one. Ingress deals with the question, what kind of data goes into the system? And there are rules and regulations stemming from GDPR that, at least in Europe, tells you how to handle personal data and data in general. So you have rules that make sure that the purpose is limited. So you can only use the personal information for a specific purpose and not for any other thing. Also, you have to minimize the amount of data. If you want to know whether I'm older than 18, you only need a yes or no. You don't need my phone number to decide whether I'm old enough to buy anything. And this is something that happens during the prompting, the inference. So we have to make sure that users of the system do not add information that is private. And even if you are not enforced to consider or take into account GDPR, the same is true for your company secrets, for customer data, for things that you want to protect because they are your company assets. Best practices to work or to employ to ensure that you are on the safe side here is to build up gateways and policy checks. So these are systems that are tied to your interface that users are working with and are checking the purpose, the role of the person, whether the consent is there, and whether only the data is accessed that this user is allowed to see. And since this really also means that people understand what they are doing, awareness and compliance programs are key here. So the main group of people concerned here are pretty much all users you are dealing with. Sanitization means you have to clean up your data before you're using it. So now we are not talking about the inference step, we are talking about training a model or improving a model through fine-tuning, retraining. And also there are rules from GDPR are applying that are enforcing you to protect the data and also do some pseudonymization of personal information. So there are 3 things you have to do. First is, if you're working from a pre-trained model, you should check what this model was trained on, because everything that the training data contained can potentially later appear in some sort of answer. Second is to redact or mask every personal information. And the third is to do a secret scanning their systems that can be configured in a way that they help you identify whether company secrets and other secrets are part of the content of your training data. It's key to to tell this your data engineers, so everybody who is working with the model, selecting models, fine-tuning, training models. The third step, retrieval, is now something that is tied to the RAG. And it's not really an AI-specific problem because we are talking about configuration access control. But the challenge is that it becomes much more critical. If you, by accident, allow a person to access a file on a SharePoint, it will perhaps take months before the person discovers that he or she has actually access to a file that he or she shouldn't have access to. It works in a different way if this happens in a RAG, because this information or part of the information might pop up in every response that a user might get for an answer without it intending to really gain this insight and access to the secret information. So best practices are build a RAG over an indexed access control corpus and respect this access control lists and levers at query time always. So this is something that is really important to make sure with your system administrators. Fourth step of the process is reasoning. It means how does the model work and how does it process your information? And there is one thing that you can always keep in mind is no training on your prompts unless explicitly allowed. It might be that a person knows a company secret and uses it somehow in the prompt. If you allow a model to learn from all the input data, it will learn about the secret and might expose the secret later on to other users. So never allow a system under normal circumstances to learn from anything that is put into the model. The second best practice is that a model should be hosted in a virtual private cloud on-prem when needed. To understand what this means and why this is a top management question is a bit difficult, and we have to step back from this 5-step process for one slide. Large language models should be an application level feature. So normally it means you're translating something, you're summarizing something, you're automating a step. It's something that happens on an application level. But often these decisions become infrastructure decisions. And this is because these models are so large and hardware resources are so enormous that choosing a model often means also choosing an infrastructure. And there are processes and costs that come with that. So basically we can differ between 3 types of setups. You can either have a public cloud from OpenAI, Gemini, Anthropic, where the vendor hosts the model and you simply access the model through an API. This has the advantage that you do not have to do much. Your resource requirements are minimal, but on the other hand, all your data leaves your environment and is processed from another company. And also the lock-in effect is quite high. Second option would be a private cloud where the model is deployed in your private cloud or your virtual private cloud by a vendor, like through Vertex AI, for instance, from Google. This has the advantage that it's much easier to contain your data, to remain compliant, but your system will become more complex. And third option would be to host everything on premise. So you run your model in your infrastructure, you have full control, full compliance, but you also have the full complexity and the resource consumption for doing that. So now you can see how the choice of the model has a real influence on how data is processed through inference and why it's so important for you as top management to be part of the decision which model is taken and what infrastructure consequences are entailed by that. Last step, egress. This means what happens with the data that comes out of the system. And this is regulated through the AI Act, at least in Europe, which means that under certain circumstances, you are enforced to do record keeping and should also have some human oversight. So what you should do as a best practice is have content safety filters. So everything that comes back should be checked whether this is appropriate content and content that the user with the given access rights should be allowed to see. You should build up tamper-evident logging to an audit store. It's a special system where every interaction is stored. And if something goes wrong later on, you have a very detailed logging where you can see what actually happened in your system. And you can build the system in a way that there is a human in the loop. It's required for all medium and high risk scenarios and domains by the AI Act, pretty much meaning if an algorithm identified something when you are prepped for surgery, you have to double check by a human, by a doctor, before removing the arm. Or if you are thinking about a use case in law, you can use information on prior decisions to make an assessment whether somebody is guilty or not. But you have to have a human to double check instead of throwing them to jail directly. And this is something that system designers have to take care of when designing a system. If you identified how AI can improve your work and your company, and you have improved the model in a way that through RAG, fine-tuning, and prompt engineering, it generates really good results, which builds trust with your employees and with your customer. And you follow these steps to make sure that you are protecting your customer data, your company secrets, and in the same time are compliant to rules and regulations that are out there. You are a big step closer to a trustworthy AI system. Thanks a lot.